Hello Victory students, this is Mr. Duncan making a quick video about the work we did today on geometric mean. First of all, the warm-up. It says write a similarity statement comparing the two triangles. We see that we have an angle congruency here, and we will have an angle congruency here at angle BDA and CDE. So by angle-angle similarity, these two triangles are similar. So we can now state that triangle CDE is similar to triangle BDA, and we have to do it in that particular order because C corresponds with B. You can see the angle markings, give that away. D is a right angle, so it has to correspond again to D as well, that same spot, same vertex, and then E of course corresponds to A. So this would be a similarity statement. Number 2 asks you to simplify radicals. You do so by factoring out any perfect squares. We see that square root of 72 is not a perfect square. However, it does factor into a product of 36 times 2. 36 is a perfect square. Now, we have a property in algebra that says that if you are taking the square root of a product of numbers, you can rewrite that as the product of square roots. So we can break this up into separate square roots. Why would we want to do that? Well, because now we can take the square root of 36, which becomes, of course, positive 6. And the square root of 2 we can't simplify any further, so we're going to leave it under the radicand. This then becomes our final simplified answer. We'll do the same thing in part B. The square root of 75 can be written as the square root of 3 times 25. And of course, using the same process, I'm going to factor out this 25, and it will become a whole number 5 on the outside, leaving underneath the radicand the number 3. So our answer will be 5 square root of 3. Next, we're asked to solve two different equations. One's a proportion, and one's an equation involving an exponential problem. So here we're going to cross multiply. When we do so, we end up with 4x equals 3 times the quantity x minus 2. We will now distribute 3. We end up with 4x equals 3x minus 6. And lastly, I'm going to subtract the 3x to the other side in order to combine these like terms. When I do so, I end up with only 1x is equal to negative 6. That will be my answer. We can verify this if we wish. 3 divided by negative 6 is a negative half. 4 divided by the quantity negative 6 minus 2, that's 4 over negative 8, which is also 1/2, negative 1/2. So they are equivalent on both sides. Solving in part B. First, we're going to simplify by dividing both sides by 2. That gives us x squared is equal to 25. To solve for a squared variable, the inverse operation of squaring something is raising either to the 1/2 power or taking the square root. Either is acceptable here. So the square root of x squared will be x, and the square root of 25, a positive 25, comes out to be plus or minus 5. So you get two possible answers. Now, depending on the context, you may only keep one of these answers, such as if this were saying, what is the length that allows this ratio to, or this equation to occur, then if it's a positive lengths only, then we would not accept the negative answer as a possible solution, so we would disregard it. But since this problem does not have any context or parameters or constraints other than what we were given here in this algebra, we will keep both answers.